Okay, so now that we have reviewed the exponent rules from our previous lesson, let's go ahead and add on our last exponent rule. So the last exponent rule deals with if we have a monomial in the inside of parenthesis, so one term inside the parenthesis, and an exponent on the outside. So before we just write down the rule here, let's make sure we understand why this rule is going to work, why we should multiply and distribute the exponent to everything inside the parentheses. So if we take a look at our example up here, we have 3x cubed inside the parentheses and then a square on the outside. So let's do this the long way. Let's write it out. This is saying an exponent means how many times to multiply the number the exponent's going to, the base. So this is saying to multiply all of this twice. So we have 3x cubed times 3x cubed. Now let's break it up even further. This is saying 3 next to an x means multiply. This is saying there's 3 of them. Another times 3. And then more times here, and there's 3 more. So now the 3 times the 3 is 9, and then there's 3x's here and 3x's here. And remember, because of the commutative property, we could change the order, associative property, move them together. Because it's all multiplication, if there was a plus here, this wouldn't work. We couldn't do this. But since everything's being multiplied, we can add 1, 2, 3, 4, 5, 6. And this would be our answer. So how did we get this 6 here without having to do every single problem this way and write it out really long? Well, if you look, to get 6, you multiply. So the rule here, without feeling like you have to memorize, we could expand it out and see the rule is to multiply the exponents in the parenthesis with the exponent here on the outside. Now, how did we get this 9? Well, we do it just like normal. We distribute. This is 3 to the second power. 3 to the second power is 9. So we're not multiplying this 3 here. We're multiplying the exponents. So now we have seen why the rule works, and now we can use it. Now, a couple things before we start with our example over here. It says, remember, if a number or variable does not have an exponent, remember everything has an exponent. If it doesn't have it, it's a 1. Okay, also, if there is a fraction inside the parenthesis, that exponent has to be distributed to the numerator and the denominator. The whole fraction has that exponent, that means. So we'll do one like that later on here. So again, why do we multiply exponents? This is saying that there's 3 of them. It means there's triple the amount. That's why we are multiplying here. So here we have 2, here we have 2, and here we have 2. Whoops. And whoops. And then you could say we have a total of 6. That's why we multiply the exponents. All right, so now we're ready to use this rule here. So when we look at this problem, we could do it the long way. We could do this, 5x squared times 5x squared times 5x squared. Or instead of doing it that way, we could apply the power rule, which says this, that I could distribute the 5 or the 3 to the 5, so that would look like this, 5 cubed. Now this is what 5 cubed means the long way. So we could grab our calculator and we could do 5 raised to the 3rd power. So the exponent button on this calculator is this little, it's called a caret key right here. This one right here, the x squared button, means the exponent's a 2. Well, since it's more than 2, I need to use this button right here for an exponent. So that's how this calculator says 5 to the 3rd power, which is 125. Okay, and then our rule here is to multiply. So 2 times 3 is 6. And that would be our final answer. Okay, feel free to pause this video and try the problem and then push play and see if you're getting it. So if we look here at the next one here, so this is -2. Notice the negative is in parentheses. So when I enter this in my calculator, I need to do -2 raised to the third power. And that would be -8. And then the rule is to multiply the exponents. So 4 times 3 is 12. And then that would be our final answer. Now, oftentimes, let me show you the error I see. I'll see people put this as their answer. That is wrong. You only move if the exponent is negative. This exponent's positive. This is not an exponent, so this should not be moved to the denominator. No, this is our answer here. Okay, so if we look at number 9 here, we have -4 in the parenthesis, and then we're going to distribute the exponents. So -4 squared. So again, if we don't use the parentheses in our calculator, because the -4 was within parentheses, it's going to give us the wrong answer. So -4 times -4 is 16. And then these exponents here, the rule is to multiply. So I'm going to take 3 times 2, which is 6. So that's x to the 6th. And then 5 times 2, which is 10. So y to the 10th. And that would be our final answer. Okay, let's go ahead and try another one here. So this is 3. So I take the coefficient, raise it to the exponent. So that's 3 times 3 times 3 times 3, which is 81. And then our rule is to multiply the exponent. So this a right here doesn't have an exponent, so it's like a 1. So this is 1 times 4, which is 4. So we would have a to the 4th power. And then -9 times 4 is -36. So I can write it here as -36, or I can immediately move it down, because when we use our rule and it comes out negative, it tells us it's going to move to the denominator. And then here we have 3 times 4, that's 12. So our final answer is going to be 81 a to the 4th, c 12 to the 12th power, all over b to the 36th power. All right, now this next problem here has these brackets here. Another way to write this problem would be -3 to the 4th power, all raised to the 5th. So those brackets don't mean anything fancy other than this might confuse people to have all these parentheses going on. So they just use brackets to know that this one closes this one. These two go together and this goes together. So honestly, they don't mean anything other than that you have -3 to the 4th, all to the 5th power. So now if I put this in my calculator and I do -3 to the 4th power. So I start inside parentheses, because these are like parentheses right here. So if I do the inside first, it's going to get me 81. And then I raise that to the 5th power. And I get this humongous answer with all these numbers. Well, I didn't want that large number, because if someone didn't have a calculator in this class, if I actually had them multiply it all out, that would take them a long time. That's a huge number. So instead, I made it multiple choice, and I want you to use your power rule to leave it in exponent form. So use the rule that we learned today. So yes, this is the correct answer if we do the inside first and then that, but let's leave it with an exponent. Which one of these gets you this answer, in other words? So let's take a look here. Let's use the power rule. So the power rule says that you're going to multiply the exponent on the outside and the exponent in the inside. So we get -3, 4 times 5 is 20. Now, none of these match this. Well, that's because it takes it a step further. You need to use what you know about your exponent rule, your negative and positive rules, and use common sense for a second and just think about this. So since this answer is none of these, I got to think about this. If I had negative times negative times negative, 20 negatives. Now, I'm not going to draw out 20 negatives, okay? But just imagine these were 20 negatives. Every 2 negatives make a positive. So the negative goes away here. And then these 2. And then these 2. So if I had 20 of them, all the negatives would match up with another negative. And the answer to this is always, I mean, look at this answer the calculator said here. Isn't this answer positive? So if you just think about it, if you multiplied 20 -3's together, a negative times a negative is a positive, another -3 times another -3 is a positive, all the negatives would go away, and that is why it took it a step further, and that is why B is the correct answer. So it is the most simplified answer, leaving it in exponent form. Now, if I check it, let's see if it's right. If I do 3 raised to the 20th power, is it going to get me this huge answer that I got putting the original problem in the calculator? And yes, they are equivalent. Okay. All right, let's take a look at number 12. So number 12, there's a couple of different ways. If you're doing it differently and getting the same answer, there are multiple ways to do some of these. So order of operations tells us start inside the parentheses. So if we wanted to, since this has a negative exponent, we can move this to the denominator. I always use that rule last. If something has a negative exponent, I move it at the end. So how I'm going to start this problem is I'm going to go ahead and distribute this exponent. So I'm going to do -6 to the -2nd power. And so -6 to the -2nd power, so that's -6 times -6 is 36. But because it has a negative exponent, it moves to the denominator. Now let's try that with the calculator. So if I do -6 raised to the -2nd power, it's going to give us a decimal, right? And then if I convert it to a fraction, it's going to show you that the 36 is underneath right here. Okay, so this is how you do it by hand. You do it without the negative. You do -6 times -6, but because it has a negative exponent, that's how I know the answer goes down here. Now we know that our rule here, when we have an exponent outside and inside, is to multiply. So -3 times -2 is 6. And because it's positive, it's in the numerator. So if you got this answer and you did it differently, great, good job. So just to reiterate here, we could have done this instead. We could have, this has a negative, it could have moved to the denominator. And remember, when it moves, the negative's gone. Now we could distribute the exponent now, or we could, if this negative gets distributed and this negative gets distributed, it's going to end up flipping the fraction around because a negative exponent changes location. So when you distribute this to both of them, it switches. And then I can now distribute. So this would be 3 times 2 is 6. And then -6 squared, so -6 times -6 is 36. So we get the same answer. This problem has probably 3 different ways to get the same answer here. All right, let's take a look at the next one here. So this is 2/5 to the 3rd power. So 2/5 to the third power. So that's 2/5 times 2/5 times 2/5. So because the whole thing goes to that exponent, we could just distribute this exponent and we could do 2 cubed and 5 cubed in our calculator. So instead of doing 2/5 cubed, we could do each one individually and do 2 to the third power is 8. And 5 to the third power is 125. Or you could do the whole thing to the third power and you could do 2/5 raised to the third power, and we get 8 over 125. Okay, now our rule is to multiply the exponent. Well, this a does not have an exponent, so 1 times 3 is 3. So we would have a to the third power. And then 2 times 3 is 6. And this would be our final answer. Okay, let's go ahead and try one last one here. So this is going to be 4. So again, there's more than one correct way to do this. One way to do this is you could start inside the parentheses. We can't simplify this. We can't subtract these because one's an x and one's a y. But you could say, oh, this has a negative exponent. I'm going to bring it up. So that's one good move you can make. And then you could say, oh, this has a negative exponent, so I'm going to flip the numerator and the denominator, and then this negative would go away. So again, I could think of like 3 different ways to start this problem here. Now, the way that I'm going to approach it here is I'm just going to distribute. I always move last. That's just my preference. I always move last. So I'm going to do this as 4 to the negative second power, and then 3 to the negative second power, and then here we're going to multiply. So 2 times negative 2 is negative 4, and then here negative 4 times negative 2 is 8. Okay, so I've distributed the exponent, and now I'm going to move anything that has a negative exponent. So here, this is 4 squared. So 4 times 4 is 16. But because it has the negative, the 16 will move down here. Now, if I do it in a calculator, actually, I'll do it after with the calculator. So here we have 3 squared. So 3 times 3 is 9, but it has a negative, so it moves up here. Now here, this has a negative exponent, so it's going to move here. And this doesn't have a negative, so it stays. And this would be our final answer. Now let's talk about if we do this with the calculator. So if we do it with the calculator, we would put in our calculator 4/3 and then raised to the negative second power. It's going to give us a decimal. Oh, no, it gave us a fraction, the 9 and the 16. So that would be our final answer.